GonioProbe.
GonioProbe. The GonioProbe.
The GonioProbe. Hi, my name is Renato Pani, and I'm a researcher at the NG Detectors, a startup whose aim is to invent, produce and commercialize the next generation of gamma detectors for medical applications. I'm glad to introduce you the GonioProbe, the next big thing in radio-guided surgery technology.
This is the first working prototype of GonioProbe. Final dimension of the instrument will be reduced to a third of prototype ones.
The GonioProbe is the world's next weapon to fight breast cancer. Nowadays, there are over 20 million breast cancer cases all around the world, and the total recovery for patients is determined by the correct and accurate excision of the sentinel lymph node, which assesses the metastatic involvement of the tumor. This technique is based on the injection of a radionuclide into the tumoral site, which localizes into the lymph node. Our team has developed an imaging system that will better quantify the radiation emitted from the sentinel lymph node and help to facilitate the surgical intervention and personalized treatment against cancer. The ability of fast and precisely localize the sentinel lymph node is expected to reduce healthcare costs and improve the successful cancer treatments all around the world, leading to an improved quality of life and health for patients. Existing systems are unable to quickly identify and quantify radiation emitted from the sentinel lymph node. As a consequence, only limited information are available regarding the success of surgical treatment. This is until now. The team working on the project is hopeful that the GonioProbe will be available commercially in the next year. The GonioProbe detects the radioactivity thanks to an innovative multi-scintillation crystal assembly. Each crystal works as an independent detector, providing a total spatial information, an accurate response about the activity of the radionuclide and the possibility of working on multiple energy windows. Now, let's see how the GonioProbe operates. As you can see right now, the GonioProbe is not detecting the radioactive surge that is mimicking the typical uptake of the sentinel lymph node because of the high distance. As soon as we get closer to the surge, it starts to give information about the leading direction. We're now moving toward the surge. Note how the count rate is getting higher. We're going to move around the surge now to test the angular response of the probe. See how accurate it is. Okay, we are on the target now. And the probe is now giving information about our distance from the target itself. We are now moving inside and outside the target. This defines the GonioProbe spatial resolution, which is about 7 mm. Look at the depth information. Let's see how, when the probe is in contact with the source, the depth recorded is of about 0.1 mm. Now, let's put a window of about 5-6 mm, and let's see how this is exactly the depth recorded by the GonioProbe.
All the characteristics that other probes consider as drawbacks are the GonioProbe's strength. The absence of a shield around the crystals allows to detect the radiation from all directions, which is the basis of a real navigation system that guides the end of surgeon to the sentinel lymph node.
It's amazing! It's really guiding my hand to the lymph node.
It's extremely light compared to the other probes.
The first time I tested the GonioProbe, I was impressed by the rapidity and the accuracy of the instrument itself. With the other probes, we spend a lot of time scanning the interested area without having the certainty of having localized the right lymph node.
During the surgical procedure, the surgeon looks for the sentinel lymph node, scanning the all interested area with the probe. They have an extreme level of radiation activity as a reference, but often it happens that once the lymph node is extracted and its radioactivity level is measured again, they realize that the lymph node extracted is not the right one.
When the first time after the extraction I counted the radioactivity from the lymph node, it was the same as before. This increased the confidence level of the surgeon toward the instrument, that nowadays is not very high as a consequence of the low reliability of modern probes. The GonioProbe's most interesting property is the navigation system. It's totally user-friendly and intuitive. Moreover, the information about the distance of the lymph node from the GonioProbe removes false negative and false positive cases.
The GonioProbe is not only the most advanced existing probe, but with a spatial resolution of 7mm and the capability of producing a system of coated images, it is the world's smallest gamma camera. Moreover, it can work with the multiple energy windows, extending its application to the multi-isotopic diagnostic procedure, preserving for each isotope the navigation system information. This is possible because the GonioProbe is 20 times more sensitive than the other probes.
Our goal was to invent an instrument that could allow the surgeon to focus only on the patient, removing any kind of distraction deriving from the instrument itself. This is why the GonioProbe put together a number of innovative features. It is the first instrument that could provide a navigation system to speed up the sentinel lymph node localization. And, as a device, it is the only one that provides information about the depth of the lymph node. As a dome, the GonioProbe is a self-calibrating system with a really fast acquisition time, which is self-adjustable on the surgeon movement rapidity and on the count rate detection to a minimum of 200 milliseconds.
I think that the only limit of the GonioProbe is the surgeon precision.
The GonioProbe is diagnosis at 360 degrees.
The GonioProbe is the beginning of a revolution.
The GonioProbe. Welcome to the future.